Okay, so continuing on, we have this problem: express 750 decigrams in or into grams. And so you would want to use, I wouldn't use decigrams because I don't have that on my chart. But if you look at the graph or the table 3.2, you can see the metric prefixes. And we have a mass that is equal to 750 decigrams, and 1 gram equals 10 decigrams, and we want to know the mass in grams. And so we're going to start. We have our conversion factor, and we start with what we're given, 750 decigrams. And of course, I would have a line straight across. And since DG is here, DG has to go on the bottom. So 750 divided by 10 gives me 75 grams. We've already done these kind of problems, so I'm not spending a lot of time on it. Especially if you're having trouble, you probably want to talk to me during class, ask a question, because if you're having trouble with it, I guarantee you someone else is. And does the result make sense? Since we're going from a small unit to a bigger unit, the number should get smaller, and that's correct. You should also look at significant figures. What is the volume of a pure silver coin that has a mass of 14 grams? Density of silver is 10.5 grams per cubic centimeter. And this is a conversion factor, and I could write 10.5 grams per 1 centimeter cubed, or I could write 1 centimeter cubed for 10.5 grams. So I have my conversion factor, I have what I'm given, and what I want to find. So I'm going to use the relationship and put 1 cubic centimeter on the top because I have grams and I want to get rid of it. And so I would start with my 14.5 grams divided by 10.5 grams times 1. And I don't have to multiply by 1, so I'm just dividing 14 by this. And I would get 10.3 cubic centimeters of silver, and that would be the volume. And does your answer make sense? Yes, it does. We have two significant figures in our given, which was 14 grams. Yeah, they actually added right here 14.0, and this should just be 14 grams. Otherwise, we would have three significant figures. And so it only has two answers, so we are correct in our reporting. Many complex tasks in your life are best handled by breaking them into smaller, manageable parts. Similarly, we can do the same thing with word problems. When we're converting between multiple units, we're going to use conversion factors more than once, multiple conversion factors, to get to an answer. This is something that will be best demonstrated in class, but you should have a basic understanding now. So, what is the diameter of a sewing machine needle? The diameter of a sewing machine needle is 0.073 centimeters. What is it in micrometers or micrometers? So we would do this using our chart. And since centimeters is times 10 to the negative 2, and micrometers is times 10 to the negative 6, negative 2 minus negative 6 is positive 4. So I would say there is 1 for 1 centimeter. There's 1 times 10 to the 4th micrometers. And that would be the conversion I would use. They're going to go from centimeters to meters and then back to micrometers. I don't think that's a good plan. So this is how your book goes through it. And if you do it my way, you'll get the same answer. And so you should go ahead and try it with my way and see if you can get the answer they got. Let me know in class if you have any trouble with that. So, converting ratios of units. If we have density, again, we can put grams per 1 cubic centimeter or 1 cubic centimeter per, in this case, 7.21 grams. And so we can then convert grams to kilograms, and we can convert cubic centimeters to cubic meters. And again, this is one I'm going to go over in class again. So you need to ask me probably not, maybe tomorrow we'll have time. So we have 1 gram is 1,000, 1 kilogram is 1,000 grams. So that's how we get this conversion factor here. And how they get this conversion factor is the one that's going to trouble you. And so please ask me in class. If you don't, I'll assume you understand it. So, problems that require the conversion factor of measurements from one unit to another can be solved using dimensional analysis. And you will use dimensional analysis for the rest of this class. Oh, we're almost done. Key factors when measurements are multiplied using conversion factor, the value is not changed, but the actual quantity measurement remains the same. So the number changes, but the amount there doesn't change. Dimensional analysis is a powerful tool used in solving conversion problems, and it makes, if you let the units do the work, it'll be very simple for you. So conversion factor, dimensional analysis, and the big idea for this section was that dimensional analysis is a problem-solving method that involves analyzing the units of a given measurement and using a conversion factor to get to another unit that you want. And there you have it. Thanks for listening, and I will see you in class.